Okay, hello. Welcome back to the basic Python course. This is session 5 about iteration. And before we start, I want to go back to the end of last session in which we wrote this program asking several questions and then pointing to similarities with David Hasselhoff. So I have, in the meantime, here finished this program. I had to introduce a further check and also commented this program. And this is how I've uploaded it to the Moodle. So you can here see that I've added a lot of information in the doc string and a couple of comments explaining the purpose of the commands and explaining how they work and explaining which parts of the objective are represented by which parts of the program. This is pretty extensive. In the documentation, you can also include links to online resources which you have used for solving the task. And yeah, so I'm not just showing this for fun. I want to once more emphasize that commenting and documentation is important. So first of all, it's important for you and the future you, in case you later get back to your code to understand why you did what you did. And second, it will also be a grading criterion for the exam that we will be writing at the end of the semester. So please do not just write down the lines of code, but also comment them and explain what your code is doing. Okay, so with that, I'll go back to my presentation. And last week, we already learned how we can depart from the usual linear program flow and introduce some branching structure. So a linear program would consist of a set of instructions that are just worked off one after another. And we saw that we can use if then else structures to form conditions, that is to do A if X is the case and to do B if X is not the case, for example. And today we want to learn a new structure which allows us to not formulate conditions, if X then A, if not X then B, but to execute several commands or perform several actions repeatedly. So by saying for n times do this and that. You can again think of this in terms of a cooking recipe metaphor that I suggested to you in the first session. So here your recipe might include an instruction such as repeat this step for 10 times, or repeat this step until the ingredient has been consumed or fully mixed into the recipe that you're cooking. And for accomplishing this, we'll again need control statements. As a reminder, control statements do not themselves produce an action or do something, but instead they are controlling other lines, or they're controlling when these other lines are run. And last week we used logical statements to form conditions. And this week we will get to know iteration or looping, which will allow us to make statements such as for so and so many times do this and this, or for each item in a list do this and that. Okay, fine. We want to again structure our learning by working towards a certain objective. And the objective is to write the following program. It should be called guesstheanimal.py, for example. And the program should first make the computer think of an animal, which in this case means to store the name of that animal in a variable. This is as far as it gets when computers are thinking. And then it should present the user with a series of 6 hints about the animal's identity. And for each hint, after it's printed out, the user has the opportunity to guess the animal. If the user just types Q, that means they want to give up and the program should quit. If they just enter nothing, ask them again. If they get the answer right, stop the game and congratulate them. If they get the answer wrong, continue to the next hint. No? I hope it's clear to everybody what the task here is. So I already show you these images. This is an African swallow, and this is a European swallow. Yeah? So keep that in mind a bit. These are the animals we will later use as examples. Okay, now at this moment, you can take a moment to think about the question, how could we achieve this repeated questioning asked for in the objective with the tools that we already know? Well, what we could do is we could write down commands which print the first hint and then some if conditions in order to check for the user input what kind of input the user has given, and so on and so forth. And then copy all those commands, paste them, adapt them for the second hint, copy and paste them, adapt them for the third hint, and so on and so forth. And while we are discussing this, we already noticed that there must be some more elegant solution. Yeah, and there is a more elegant solution, which is iteration. There are a few examples of iteration or writing loops over just copying and pasting code multiple times. And these advantages are clarity, robustness, and flexibility. So first of all, with an iteration structure in your program, it is much more clear to the reader of the code what the program is doing. This is a clarity point. Second, when you are copying and pasting the code and adapt it to a new situation, for example, second, third, fourth, and so on, you may make errors. This is very laborious and it's error prone. So, for example, you forgot to make one modification when you're adapting it to the third hint, or you're forgetting another modification when you're adapting it to the fourth hint, and so on. So this is a robustness point. And third, also very importantly, with an iteration structure, your program, you will be more flexible when you are adapting or modifying the program. Which means that if you want to change, for example, the way the hint is presented to the user, or if you want to change how the user input is asked for, or if you want to change the conditions that you're doing, you do not have to change them for each hint one again and again, but you can just change your control statements and if conditions once, and this will take effect for all the hints that are being presented and asked. These principles are actually so important that there is a specific name for these rules, and this is called the dry programming style, where dry stands for don't repeat yourself. So we don't want to repeat code and repeat it and repeat it and repeat it again, and then always manually modifying it, but we want our program to be concise. This is in contrast to a wet programming style, where wet stands for write everything twice, or also sometimes we enjoy typing. So we don't want to write everything twice, and this is why we use loops and iteration structure to accomplish the objective that is on task today. Okay, so with that, I'm switching to the Spider IDE, and we're going to start coding. So I want to open a new script. And in that script, I want to define our well-known shopping list. And I'm doing that because we have already learned some kind of hidden loops in one of the previous sessions, because we have already learned how to use list comprehensions. So in one of the previous exercises, I think, the task was to discuss what the following command results in. And this command in line 9 is to be read as, for each item in the list shopping list, take this item, take the first two elements, which in this case would be the first two letters, uppercase them, do this for each item, and collect all the results in a new list, which is then printed on the next line. So this program results in the following output we get for each item in the shopping list. The first two letters in uppercase form. Now, as I said, this is already some kind of loop because it allows us to do something for each item in a list, but it has the disadvantage that you can only do one operation for this item. And actual loops allow us to do several things for each item in a list. And in Python, loops are constructed in the following way. For item in shopping list, colon, new line, indentation, print, next item of shopping, and then print the item, and then afterwards print the end. So if we are running this program, the code again takes each item, which is in the list, which we have to find up here. And for each item, it prints the string next item of shopping, which is identical for all items. And then there's another print command, which prints the item itself. And what we get is this output. So for each item, we get the line next item of shopping and the item itself. And then at the end, we get another line saying that this is the end of the shopping list. Okay, great. So once again, here is the general syntax of for loops in Python. We write for, then we pick a variable name, which we can choose, then in, and then an iterable data structure, such as a list. I will say more things about this in a few minutes. Then colon, new line, and indentation. So here, just like with the if clauses, indentation is important again, and indentation signifies to what commands the control statement exerts its influence. Yeah. So as a reminder, if we move this command into the loop, the print the end command, and run the program again, we will not just get the end at the very end, but we will get it in each iteration of the loop, simply because it has been indented, which is signaling to Python that this is under the control of this, that this is under the influence of this control statement, the for loop. Once again, the name of the iterated variable is arbitrary, so we can also change this to ABC as long as we then also change that in the loop, because this is the only way for Python knowing what we are referring to. So this also works. Okay, I just said that this the variable that comes after in should be an iterable data type object. And what does that mean? That means that it has to be of a data type which can be worked through or worked off in some or the other way. We know that lists can be worked off because they are sequences. That is, they contain more than one item, and these items are in a specific order. And the for loop will also follow this order. And the same is true for tuples. Yeah? So if we would define this with round brackets instead, this would create a tuple and would also allow to run this for loop. Okay, so we know that lists and tuples are iterable. Let's explore some other data types which we know and find out whether they are iterable. So an interesting question could be whether strings are iterable. So let's just define a name. And then write for item in name. And because we know that it's arbitrary which iterated variable we choose, we replace this with letter for each letter in the name. Print next letter in name. Print letter. Okay. Sorry, I'm commenting this here because I don't want it to be executed all the time. Good. So what this program is doing, it takes the string Elon Musk, and a string, as we know, is nothing else than a sequence of characters. So the for loop will run across the characters of this string. And then for each character, we will print the line next letter and name and the character itself. And this also holds true for the space, which is a character. It's not a letter, but it's a character in this name. So spaces are not being omitted if you iterate through strings just because they are non-printable characters. Okay, so we know that strings are iterable. Let's ask about integers. So, for example, if we write for x in 42, print x, whatever this means. So let's find out whether integers are iterable. And we get a type error. Int object is not iterable, which is quite plausible because there's nothing that you can work through in an integer number. Let's try the same thing for floats. So we're typing for x in 42.5, print x. And we get the same error. A float object is not iterable. So integers and floats do not belong to the iterable data types. Then I think 2 or 3 weeks ago, we introduced another data type, which is the range data type. We defined a variable called 10 numbers, and it was defined as the range of numbers starting from 1 up to, but not including 11. So basically all the numbers from 1 to 10. And we also learned that strangely, if we print this, we only get the output range 1 to 11, which basically tells us nothing that we didn't already know, but that those range objects can also be converted to lists, in which case they are containing the actual numbers. Now it turns out that range objects are iterable without converting them to lists. So we can for example, write for x and 10 numbers, print x squared is x squared. And if we run these commands, they gonna give us this little table of square numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, up to 10 squared is 100. So what these lines are doing is that taking each item from the range object, and we know that the range object contains these 10 numbers, and then for each item it prints these item, the words squared is, and then the square of this item. And this works very well. So to summarize one more time, integers and floats are not iterable. Lists, tuples, and strings and range are iterable. The last data type, which I think we got to know, was a dictionary. So we can ask ourselves whether dictionaries are iterable. For that, I've prepared a little script here. Let me open this. Okay, so here in line 1, I'm defining a dictionary, which is also the one I think we have used 2 or 3 weeks ago. As a reminder for you, dictionaries are created with curly brackets, and they contain name value pairs or key value pairs, where each key is a string giving a label, and then each value is some other thing, can also be string, can also be an integer, giving us the value behind this label. Okay, now we just try to iterate through this dictionary by typing for x in info, whatever x will be, print x. And if we run this, we find out that x are the keys. That means that dictionaries are iterable, but please keep in mind that you are iterating through the keys of the dictionary, not through the values. There is a way of iterating through the values, which is just using the dictionary method values, which, as you know, returns all the values in the dictionary as some kind of list. And if we then iterate through info.values, we find that we are in fact printing the values. Oftentimes, it is not really useful to either have all the labels or have all the values, because the information really consists in the pair of keys and values. So if you want to iterate through both, you can use the following structure. For key, comma, value in info.items, colon, new line indentation, print the key and the value, separated by colon again. So what this does is this applies the dictionary method items to the dictionary info, and the dictionary method items creates a list of pairs, where each pair consists of the key and the associated value of this key. And then with this notation, we are kind of unpacking this pair. So from each pair, we are extracting the key and the value. And in each iteration of the loop, we are working on one pair of key values. And we're therefore printing the key and the value at the current iteration. So if we run this, this looks like this. And this is much more informative than the previous versions because we're getting the labels of the keys and the values. There's a similar structure which you can use for lists. Of course, for lists, we don't have keys, but we have indices. And oftentimes, what you want to do, you want to, in your loop, use the item from a list itself, but also its index. So whether it's the first, second, fourth item, and so on. And for that, you can use the enumerate function. So enumerate is a built-in function in Python. Here's an exemplary application for index, comma, item in enumerate shopping list, print, index, comma, colon, item. So what does enumerate do? We can find this out by just applying it to the shopping list. So if we apply enumerate to the shopping list, this is an enumerate object. And if we convert this to a list, it looks like this. We get a list indicated here by the square brackets. And each item of the list is a tuple consisting of two elements. Tuple of two elements is called a pair. And the items of this pair are the index of the current item in the shopping list and the item itself. So this pair is then taken in each iteration and broken down into the index and the item, which can be used as separate variables during the contents of the loop. So if we run this command, we're getting something like this. 0 eggs, 1 bacon, 2 pudding, 3 sausages, 4 bread. And now we are reminded once more that Python uses a very strange way of counting. So if we want to adapt this to ordinary language, human counting, you should use index plus 1 somewhere in your loop. And this will then generate the following output. Good. Now let's discuss indentation again. So we have already seen that indentation in for loops is similar to indentation in if clauses, in the sense that all the lines which are indented are controlled by the for loop. But we have not yet looked at nested indentation. So last week, we were discussing an example in which we used an if clause, and then if the condition in the if clause was triggered, there should be another if clause asking for another condition. And this was an example of a nested condition. And here we have an example of nested loops. So in this script, the script defines a list of strings, which is called spelling bee, and which consists of a couple of hard words or words hard to spell. And then we have two loops. We have one loop which is running from line 3 to line 7, and we have another loop which is running from line 5 to line 6. So let's just call them the outer loop and the inner loop. Now, what we can see is that the outer loop goes through all the words in the list spelling bee. Yeah. So this is a list. Lists are iterable, and the items in the list is what is being iterated through. So each word here will be one item from this list. Then it prints the letter in this word R. And then there's a second loop, the inner loop, and the inner loop goes through all the letters in the word. Here we have an instance of enumerate. So enumerate is being used to generate the indices of all letters and the letters themselves. And then each letter is reported together with its index. Then there's an empty line, and this is repeated for all the words in the list until we finally get the end message, end of the spelling bee. Okay, fine. Let's have a look what happens if we run this program. So just as expected, the program is generating output for all letters in the first word, then for all letters in the second word, and then for all letters in the third word. Yeah. So this is an example of multiple indentation in order to create nested loops. And you also know that in defining the inner loop, you can use the iterated variable of the outer loop. This is absolutely possible. So in this case, we are going through all the letters of the words. And if we go up one level up in the hierarchy, we're going through all the words in a list. Okay, I think with that, we have all the necessary prerequisites to start writing our program. And I have here prepared something, African swallow, which will serve for us as a starting point for our program. So I'm copying this to a new file, which I'm going to call guess the animal. And let's have a look at what is already in that program. So we here define a variable correct answer. This is supposedly the animal that should be guessed by the user. Then we have a list, which consists of a set of strings. So these are supposedly the hints that should be presented to the user. In the objective, was asked to be 6, but we are for now starting with 3 in order not to make it too time consuming. And then the computer prints the list. I'm thinking of an animal. Fine. After that, we are starting a for loop by saying for each item in the list hints. So we're going to designate our item with H. So we're going to say for H in hints, print this hint. So say hint, and then it, for example, is not migratory. And then ask for user input. One moment, please. Okay, back in the recording. So we have a first skeletal version of our program. And first question we can ask is, how can we use the if and else, which we already know from last week, to check for whether the user has given the correct answer? Well, obviously, we should compare the user input, which is given by guess, to the actual correct answer. So we type if guess equal to correct answer, colon, new line, indentation. We print correct. And otherwise, we print not correct. Okay, great. So let's try out this version of the program. I'm thinking of an animal. It weighs 5 ounces. What is it? Let's say it is the European swallow. Not correct. It beats its wings 43 times per second. Then it may be the African swallow. Correct. But now there's another hint. It is not migratory. But I already got it right. Not correct. The end. This is, of course, not very good because the program is not stopping as soon as we give the correct answer. It's still continuing to print the hints. And why is that? Well, it is because if the guess is equal to the correct answer, we're only saying the program should print correct. There's no way for the program to know that this should also result in in ending the loop. So it's very easy to fix this error, uh, namely using the keyword break. So entering break somewhere in a loop breaks from this loop. That means it escapes the loop and further iterations of the loops are not being performed. So what does it mean? That means if we run the program and then enter African swallow as our first guess, that's correct. And this is the end. So now only the first hint was being presented. And since our guess was equal to the correct answer, we broke from the loop, which meant that the loop was discontinued. Now, next question. How could we use if and else or if and break more precisely to implement the quit option? So first, let's modify the instruction here a bit and say it reads, what is it? Or type Q to quit. So then obviously before we're checking for the correct answer, we formulate another if condition, which says if the guess is equal to Q, break from the loop. And here we can also add an informative message. For example, so you're giving up. Well, then goodbye. Let's try that out. I'm thinking of an animal. What is it? Is it maybe the European swallow? Not correct. I don't get it right. I want to quit. So you're giving up. Well, then goodbye. And the end. Perfect. So with that, we have already introduced two requirements from the objective into our program, namely quitting if the end user inputs Q and printing correct and stopping the program if the guess is correct. So next, we see that in the objective, we're also being asked to configure the program in a way that if the user enters nothing, we just ask them again. So in order to build this into our program, we first have to find out what result we get for an input if the user enters just nothing. So let's try that out. I'm opening empty input. And instead of now typing something, I'm going to delete everything and just hit enter. Now we have a look at guess. And we see that guess is a string of size 0, which contains nothing, not a single letter, not a single space, nothing. This is called an empty string. Now, how can we check whether a string is an empty string? Well, there's a couple of ways of doing that. First, we could just compare the string to the empty string to see whether it's empty. So this gives true. indicating that the check succeeds and finds out our string is empty. Then we can also ask for the length, because you can see here that the length of the string is 0, and the empty string is the only string of length 0. So you can ask whether the length of the string is 0. And this is also true. And finally, a rather interesting way of checking this would be the following, namely to simply ask if whether not bool guess. So maybe you remember that when we introduce conditions, that all empty strings are false and non-empty things are true. This means that if the string guess is empty and we convert it to Boolean variable, this should give false, and not false is equal to true. So this is also true. And this can even be shortened to just typing not guess, because Python automatically does the Boolean type conversion in this case. Okay, so to summarize this, we have three equivalent ways of checking whether a string is empty, which are these three, and I'm gonna go with the simplest one. And see whether it works. So what is it? I'm entering nothing. And now I'm entering something. And it's being recorded. Great. But what now happens if I run this program and enter nothing twice? Then we still have an empty string. So instead of just checking whether the string is empty using if and then asking once again, we need to ask again and again and again as long as the string is empty. And for that, we'll need a new structure, which are while loops. So while loops work as follows. I'm going to comment this line here and say while guess is equal to the empty string, ask for more user input. So this is the general syntax of the while loop. You have to type while, this is a reserved word. Then a logical statement, just like in an if condition, colon, new line, indentation, just as it's being done for all control statements, and then something that should be repeated as long as the logical statement after the while is found to be true. Yeah. So if the string is still empty, ask one more time. If the string is still empty, ask one more time until the string is not empty anymore, in which case, don't ask one more time. Okay, let's try that out. I'm entering nothing and entering nothing the whole time. And then I finally enter something, and the while loop stops because the logical condition here was found to be false and didn't have to ask one more time for the user input. Great. So I'm copying this part of the code into our script. In order to also fulfill this requirement of the case. So here we are asking for user input, and then if the user input is empty, we're repeating to ask for this. Let's check whether that also works. So we are in the first hint now. I'm entering nothing, and then I'm finally entering something. Second hint, entering nothing, and then finally entering something, and that's correct. Okay, so with that, we have basically implemented all the checks required by our objective, and the program is final. You just have to add a little more comments and documentation, and you find a documented version of this script on the website, just like always. One word of caution before we end. So you should be aware that while loops can run forever. Yeah? This is called an Endlosschleife or endless loop. So if your while loop is defined in a way such that the condition cannot become false, it will repeat and repeat again and again and again until the end of the universe. So please, if that happens, you can either break your program by pressing Control C, or you can also hit the red square here in the console. And if you click this, the program is also being stopped. And then if you found out what the problem is, why you have an endless while loop, the solution is just to put something into the loop which allows to make the condition true that you have defined after the while. So in our case, this is this statement. This statement allows to make, so this command allows to make this statement false eventually, namely if the user enters some meaningful input that is not the empty string. So there are, again, two exercises at the end of the lecture notes. The first one is a continuation of our program, Guess the Animal, that we have written. For that purpose, you'll find here a full version with comments and documentation in the lecture notes. And in the second exercise, you should come up with an own loop of yourself in which you kind of generate this nice multiplication table for a given input number that is given by the subject. Okay, so with that, I want to say thank you for listening and hope you enjoy the other videos as well. Thank you very much.